Hi everyone, welcome back to Java with Hawa. Today I'll be solving 2-sum 2 where the input array is sorted. So it says given an array of integers numbers that is already sorted in non-decreasing order, find two numbers such that they add up to a specific target number. Let these two numbers be numbers at index I and numbers at index 2. Oh, it says 1. So numbers at index 1 and numbers at index sub 2, where index is greater than or equal to 1, and index, okay, I guess 1, okay, whatever. They're just adding 1 to the index. I don't know why they had to do all that. Like, they're doing too much. Anyways, return the indices of the two numbers, index sub 1 and index sub 2, added by 1 as an integer array. Index sub 1, index sub 2 of length 2. The tests are generated such that there's exactly one solution. You may not use the same element twice. Your solution must use only constant extra space. Okay, so, oh my god, I have 9%, oh my god, I have 8%, so I have to explain this in literally 8% of time. I think I can do it. This one is not too hard. So this example they give us here, we have 2, 7, 11, and 15, and the target value in this case is 9, and the output is the index 1 and index 2, because at index 0, we have the value 2, and at index 1, we have the value 7. And we know that 7 plus 2 is equivalent to 9. So we need to return the indices of these numbers that add up to the target value, but we're just going to add 1 to them for the sake of the solution. So we add 1 here, and we get 1, and we add 1 here, and we get 2 in the solution. And note that they say that we can assume exactly one solution. So this problem is nice because the input array is sorted, so we can actually use properties of basic algebra to know to use constant space first of all, and also to have the most optimal iteration. So of course you guys know like the regular two-sum where you can use a map which will take O of n space at most, or you can use a for loop, double for loop that will be O of n squared that goes through each of these values and then checks the corresponding ones and sees if they add up to the target. But we have the extra caveat that we have a sorted input. So let's write our input here one more time. And target is equal to 9. Alright, so in this case it's super simple. What we're going to do is use the two-pointer approach. So we'll have one pointer starting at the very beginning of the array because we know this is sorted. So we know that the lowest value would be on this side. And we'll have another pointer starting at the end of the array because we know that's where the largest value would reside inside this array because it's sorted in non-decreasing order. So once we have that, all we have to ask is, do the values at both of these pointers add up to my target? So we can say something like, so if this is nums array, we can ask ourselves, does nums at 0, in this case we're at index 0, and nums at nums.length, so plus nums, and I think nums.length 1, 2, 3, 4 minus 1 is 3. So you say, does this equal to the target? Okay, so if it does, all you have to do is return the index of both of those values. So you return some array that contains index 0, but in this case they want us to add 1 to every index, so that will be 1, and the one that contain whatever index we're at, so it'll be like index 3. Okay, that's if it's equal to target, right? But in this case we see that 15 plus 2 is not equivalent to 9. But notice one property is that 15 plus 2 is actually greater than 9. So here we have the case where nums at 0 plus nums at 3 is greater than target. And if it's greater than target, if 15 is greater than target, we'll know, okay, this is a sorted array. That means I'm way past my goal, and I need to move this pointer to a lower value because I know this is sorted and I know 15 is the largest value in this array. So let's move this higher pointer down by 1 and see if that gets me closer to the desired target of 9. And really the goal of this mechanism is to try and get closer and closer to the target. So if you're way too big and you're greater than the target, then you know that you need to move downwards. You need to go to smaller numbers so that you can potentially have the opportunity to add up to your target value. And likewise, we have the last case, which is if you're less than the target. So if nums at 0 plus nums, in this case I guess 3, is less than the target, then you know that, okay, this is the smallest number in this array. So at this point, you know that you need to move upwards to larger numbers because this is sorted, so that you can potentially reach the target of 9. So here you'd move, I guess, 2 to 7 if this were less than the target. But you can see that 15 plus 2 is greater, 11 plus 2 is greater. So we're actually going to keep moving this higher pointer downwards until it gets to 7, and then we have 7 plus 2, which equals the target. So basically, as I said, the idea is that you get closer and closer to your target. If you're greater than your target, you move downwards because you know you need to get to smaller and smaller numbers so that you can add up to the target. And if you're much less than the target, you need to move upwards because you know that you want to get to larger and larger numbers until you reach your target. And if you're equivalent to your target, you just return the indices of where you're at plus 1. And that's literally all the logic for this problem. Hopefully that makes sense, and then we'll code it in the next section.